Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 14, and the topic is the self-potential method, also known as the spontaneous polarization method, and the book which I referred is the Introduction to Geophysical Prospecting by Dobrin, Outline of Geophysical Prospecting by Ramachandra Rao. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. So let us see an outline of how this method has been started. Actually, it was in 1815 by Robert Fox. He is one of the earliest pioneer of exploration geophysics, and in 1815 actually he discovered that certain minerals exhibit spontaneous polarization. And not only that, actually he proposed to measure of this effect can be used as a mean for prospecting of such an ore. So it was his theory to propose this. Actually, it took nearly a century to prove it in field, that is in practically. That is by Conrad Schlumberger in 1913. Actually, he in 1913 has used this self-potential effect to locate a sulfide deposit successfully at bore. So this is how this method has been evolved. So let us see the basic principle of this method. So this method of prospecting is based on the measurement of the electrical potential that is naturally present in the earth. It is also known as the spontaneous polarization method, or shortly known as the SP method. There are several sulfide ores like pyrite, pyrrhotite, chalcopyrite, molybdenite and cobaltite that actually show spontaneous polarization. Not only that, actually anthracite and graphite are well known for its SP value. So let us see actually how this works. That is how actually the SP value is produced. So for that there are actually two theories. Let us see one after the other. The first one is known as the oxidation theory, according to which when a ore body is exposed on a surface and it is uh, extending downwards, the upper portion, that is appearing nearly above the groundwater level or near the ground surface, that get oxidized due to the presence of free oxygen. When there is rainfall, that is appearance of meteoric water, this upper portion get dissolved and that liberates the H2SO4, which actually percolates down below the water table. And what happens there, actually the precipitation takes place, and by this way the sulfide is getting enriched, and this method of ore deposit is also known as the supergene sulfate enrichment. So this is how this and reduction is taking place in the same ore body, which leads to the two different electrochemical activity, and that is the main reason for this spontaneous polarization. This was the very first theory, which is also known as the oxidation theory. The second theory is proposed by Kelly in 1945 and Sato and Monet in 1960, that the SP effect is due to the hydrogen ion concentration, which is also known as the pH value of the water, that is above and below the ore body, and that actually gives rise to the self potential values, where the upper become the negative charge and the lower become the positive charge. So this is the second theory. So these are the two main theories for the origin of this SP effect. So whatever the theory that is accepted, that is not of our main interest. The current passes through the ore, actually down through the ore body, and comes to the top by the surrounding ground. So the ground immediately above the ore body will therefore shows a lowest potential, which is also known as the negative center, and this negative center is the target of our SP method. So this is what we are actually looking for, that is the negative center in the area where we are actually working. Okay, so this is the reason for this SP effect. So let us see the field method, actually how to go for the field search of this mineral. In electrical prospecting, actually a thousandth part of volt, that is a millivolt or MV, is used as a unit of measurement. As you know, the potential difference at the surface of the earth arises from the electrochemical activity of an ore body, may vary from say 100 to 500 millivolt, or even it may sometimes reach 1000 millivolt. So depending upon the nature of the electrolyte present, the conductivity of the ore body and the depth below the surface. So this is the main criteria for the value of the SP at a certain location. So the negative center can be located either by determining the line of EQ electric potential directly on the ground, or by measuring or measuring the SP value at different points that is lying in an array. And after doing that, what we can do is we can simply plot the contours for that array, and we can simply find out the negative center. So the left side image shows area which has been separated into grids, and in each grid what they do is they will be measuring the SP value at every point, and after that what they will go for is they will just prepare contours. Just by preparing contours they will get an idea where actually the negative center is. Okay. And in general, the negative center will be the area that is enclosed by the equipotential line having a lowest value, and the ore body is often met below the negative center. So this is the field method for this. So let us see the instrument which is actually used to find out this SP values. So actually what they will do is they will go for the non-polarizable electrode. So let me explain you what is it and why actually they are going for this. So what you call the generally polarizable electrode, what we are using is actually when get in contact with the ground, that produces spurious potential that is in the range of say 100 to 200 millivolt, which is in turn in the magnitude of the self potential value. So we cannot use this kind of regular polarizable electrode. So what we can do is we can go for non-polarizable electrode, wherein any metal that comes in contact with a solution, it always occurs a potential that is called a single electrode potential. If two electrodes that made of same metals are alike in every way and are placed in a contact with a solution having the same concentration at both the points of contact, there will be no difference in potential between these two metals electrode. Okay. And if a pair of such electrode each having a rod of same metal dipping in a solution of same salt in equal concentration is used to contact the ground, the effect of electrode becomes negligible, and this is the actual principle behind the working of this non-polarizable electrode. And in most non-polarizable electrode what we can go for is the copper rod, that tube is dipped and the saturated solution of copper sulfate. So in the left side image shows you general sketch of a non-polarizable electrode where there is a connecting wire is present at the top, and there is an opening cap for filling the solution, and here is the closing of the top of the container, that is a cap, and this is the solution of copper sulfate, and this is the rod of the copper sulfate, and there are also copper sulfate crystals on the bottom. And this vessel is actually glassed here, and here it is unglassed, where this liquid is get into contact with the ground surface, where if there is a presence of any SP value, that leads to the additional solution of this copper sulfate, and that can be measured using this wire that is in the potentiometer. So that wire is connected here in the potentiometer. So the voltage between 2 points on a ground picked up by the non-polarizable electrode may be measured by the potentiometer, that is shown in the sketch shown in the left side image. In its simplest form, the potentiometer consists of a long resistance wire. So this is the long resistance wire, that is an R of an uniform cross section with its two ends connected to one terminals of a standardized cell. The EMF will be distributed uniformly along the length of the wire from A to B. So the unknown potential difference between the point, that is N1 and N2 on the ground, may be determined by connecting the electrode N1 with an insulator cable to A. So this is an insulator cable which is connecting this N1 to A. And similarly the other electrode N2 through a galvanometer to the side that connects the B. Okay. So the voltage between N1 and N2 may be then determined by finding the point C on the wire when no current passes through. That is, when the galvanometer shows no deflection. In such a condition, the balance of voltage between N1 and L2 will be equal to the distance between A to C, which we may read off from the scale as the potential difference between A and B is proportional to the length. The wire may be calculated to read in millivolt. So this is how the SP method is done in the field with the help of a non-polarizable electrode and a potentiometer. So let us see the interpretation, which is quite interesting. Qualitative interpretation of SP data will be usually be adequate to make out a position of the negative center, below which the ore body is usually found. However, under certain favorable conditions, the interpretation may often be carried a step further. That is, for a quantitative method to obtain an estimate of the depth and the dip of the ore body, the potential value measured in the ground depending on the electrochemical condition of the causative body, the distance of the observation point from the source, and the resistivity of the rock formation. The potentiometer of equipotential line relating the SP indicates usually gives some idea of the shape and attitude of the causative body. The SP anomaly curves produced by the sphere, a rod, and a sheet of a ore body have been calculated from theoretical consideration. By comparing an anomaly curve obtained in the survey with theoretical calculation curves, an approximate idea of the shape and depth of the causative ore body can be obtained. So this is how they are interpreting the SP values. So let us go for the application. The SP method has been created with discoveries of several important deposits of copper ore, pyrite, pyrrhotite, molybdenite, graphite, and occasionally of pyrolusite. Discoveries of copper ore, pyrite, and nickeliferous pyrrhotite has been reported from USA, Canada, USSR, France, Sweden, and other countries of Europe, Australia, and South Africa. So in India, the SP survey has been carried out by the Geological Survey of India that covers many of cyst belt of mineralized area in various states. Promising results have been reported from Chandradurga cyst belt of Mysore, the Shingbung belt of Bihar, the K3 and Dadri belt of Rajasthan, and several other isolated locations. At Inglabad in Chitradurga belt, that is SP indications led to a discovery of a massive pyrite deposit that is associated with a Cherty formation occurring at contact between the chloride cyst and the ancient volcanic rock. That is by Rao and Rao in 1957. The maximum SP anomaly noted was 160 millivolt, and the figure in the left side shows the SP anomaly map. And as a result of detailed prospecting and drilling operation carried out by the Mysore Geological Department, it has been estimated that about 1 million tons of pyrite ore body present in that area. I hope this will give you a generalized idea about the SP method, and I will be concluding the SP method here. If you still have any doubt, you can just ask me in the comment section, or you can just contact me through my mail or Facebook ID. You can just check out other videos in our playlist which I had made already. You can connect with us by mail, Facebook, and Instagram, and these are the links. You can support us by like, share, and subscribe. Thanks for watching. Have a great day.
Fed up with online classes? Having trouble in interaction and discussion in online classes? Looking for one-to-one learning? Then you are in the right place. GeologyAssignmentSupport.com is here to help you in your studies. For more details, check our website. Link is in the description.